Before telling you a couple of things that major things that can go wrong with bar graphs, let me show another application of bar graphs. Remember, bar graphs are supposed to describe frequencies, and so the length of the bar graph of each of bar of the bar graph tells us what percentage of the observations had the appropriate value. And therefore, when we add them all up, like in a pie chart, they should add up to 100%, but not always. We can we can use bar graphs to compare percentages across several dichotomous variables. What does that mean? Remember, a dichotomous variable is one that can take only two values, yes or no, true or false, dead or alive, and things like this. Here is an example. Okay, someone did a study on teenager attitudes towards smoking and came up with this bar graph. Okay, now notice that each of the bars represents a different question that the researchers had asked to the subjects of their study. So, for instance, they asked them if they recalled a certain smoking ad, and 62% of them said yes, so that bar reflects as 62%. Now that's done with that variable. Move on to the next variable. Smokers exhibit good judgment. What did they think? Do they or don't they? Well, slightly less than 40% of the teenagers interviewed thought that smokers do exhibit good judgment. And so that's the second variable that we are listing. Okay, so again, we can use all these bars and we can compare these things. We can see, for instance, that teenagers remember very vividly, or in the grade numbers, we don't know if they recall it very vividly, but certainly in grade numbers they recall smoking ads. And that goes to show that again, that advertisements can be very effective in influencing young people. On the other hand, the young people are very well aware of the fact that smokers really do not enjoy life more. In fact, smokers enjoy life more had the least percentage of yes answers. Okay, so the teenagers seem to be realistic, and this shows up quite nicely from this particular bar graph. So once again, if you add up all those percentages, we're going well above 100, but that's because we're talking not about one variable and different values, but about several variables for each of which we're representing the proportion of yeses. Okay. So now let's have a look at, yeah, right, so the total it can be more than 100% in this case, but in general, if you're talking about just one variable and we're listing the values of that variable, then those bars should add up to 100%. Now, how can bar graphs be used incorrectly? Well, first of all, bar graphs must describe frequencies. Otherwise, what happens is that you may end up with a misleading bar graph, or like this one, for instance. Okay, and this one is a bar graph, and actually it's the 3D one. I'll say something more about it in the next little video. But if you actually look at what those bars represent, they are not percentages. Granted, it looks like they're three different variables, but they're not. They're actually mean scores for a certain questionnaire in three groups of people. So they do not represent percentages, but they represent means. Well, what's wrong with that? Well, not much, except that using a bar graph in this situation means that we're missing a lot of information about the individual scores. For instance, all of those bars start at 0. Does that mean that in each of those groups someone scored 0? If not, what was the minimum value? Well, what was the maximum value? You know, I mean, the mean score, for instance, of the highest bar was a bit over 90. Well, how big was the biggest score that was obtained? What were the quartiles? What was the dispersion of the data, with the variability, right? What can we say about range, interquartile range, and things like this? All this kind of information gets totally lost when we use bar graphs to represent things other than the percentages. So keep that in mind. But there is more. Just stay tuned.